So here is how to create code for your inventor part in Edgecam. So we load up Edgecam, click open to select the part, and it should look like this. It's a side view. If I right click, I can rotate this so that I can see it a little bit better. Using the hand clamp, we need to set our 0, 0, 0 in this corner. So to first do that, we need to auto stock. So that should be the button that looks like this. It might not be in this location, but it should look like this. Yours might be on the right hand side. And ooh, it just did it automatically for me. Occasionally it does not do that. It opens up this menu, and then you need to make sure that this is checked, and then you click OK. Now it looks like I've stocked it twice, so if you've done that, just delete one of them. So here is my stock. At this point we need to create our CPL, so that's in Geometry, Create CPL, and click Origin, name it whatever you want. This is my favorite name, APDSTY. Then go through 3 points. This means the name doesn't matter. Whatever you type in there is fine. You just can't type the same thing in twice if your CPL makes a mistake. So I'm going to click OK. And the first point is going to be this corner. You need to make sure that the red box shows up. You can't just guess. If it looks like it's there, but the red box doesn't show up, it's not there. So that's the first click, and you see the dot appears there. That's what you want. Second click is on the right hand side. Third click is in the top. That's our y-axis. And then the fourth click is back to the origin. And our CPL should show up there. X is the red line, the y-axis is the green line, and the z-axis is the blue line going straight up and down. So that's exactly what we want. Then the last thing that we do is Feature Finder, which is this button up here, the little glasses. And we're going to click Mill. And what we're going to look for, if you have holes drilled in it, you need to select Find All Holes, max diameter 0.5. And these options are good. For milling, you want 2D pocket, 2D boss, 3D pocket, 3D boss. And that should find everything we need. So we're going to click OK. And it found all the features. There's the outside lower part, here's the inside or outside edge, and here's the inside pocket. If it doesn't find them, you just got to open it up, you got to start it over, you got to recreate your CPL and try it again. If your CPL is slightly off or you thought you clicked something and you didn't, it won't find your features, so you're going to have to redo it. Once we've done the CPL, you click Manufacture Mode. If you click this too early, it will create your CPL for you in the wrong place, so it won't work. So we should be under Discipline Mill, Machine Tool ProLight. If ProLight's not in your computer, I need to load it into there. Then we click OK. And loading, 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 loading. And loaded. So now we're going to rough out the inside. So up here you're going to have some icons somewhere near the top. Yours should look something like this. This one is roughing. So we click roughing. And I want to rough the inside. So I need to go over here to my features and find out which one is the inside. So which one is it? And yes, you're right, it is 2D pocket. So I click that, and then I push the enter key once, and I push the enter key twice. And so you click that section, you push enter twice. Then you're going to set your roughing operation options. We're going to set ours to optimize so it cuts in both directions. You can see the little arrows both directions, whereas this is one direction. 50% step over is fine. Tooling, a feed rate of 20 is probably fast enough to rough. We don't want to go, 30 might be a bit too fast. Plunge rate of 10, speed of 4,000. And we're going to cut with a diameter bit that is a 1/4 inch end mill. And you can see end mill is a flat end there. If it's a ball mill, we would have an 1/8 inch diameter, but it is not, so we're going to leave it there. Do not go to your tool store. That's going to screw everything up. And our depth, we have a clearance of 0.25. Your cut increment is going to be defined based on the object that you cut. A general rule of thumb is not to go more than the thickness of the bit, so don't go more than 0.25. So what you should probably set this to is an even increment of your depth. So if I'm cutting at 0.6, 0.6 divided by 3 is 0.2. So if my depth is 0.6, I'm going to set this to 0.2. If my depth is whatever, then set it to maybe like 1/3 of that or 1/4 of that. I'll probably give you specific guidelines for this. So I'm going to leave it at 0.22 for now, because I think that's about 1/3 of my current depth. And you can see it mills it out. The last thing we're going to do is profile the outside edge. So profile just runs along a border. It doesn't mill everything out, but you always have to profile the outside edge. So we're going to profile the 2D boss, and I push enter twice, enter, enter. And my profiling tool, it's going to be the same, optimize is fine. We need a lead radius of 0. We don't want this to zoom out of the box, so we don't want to hit the clamp, so 0 is fine. Tooling 20, 10, a speed of 4,000 again. Same diameter, no radius. And set your cut depth to about 1/3 of the depth, or maybe 1/2 of this depth, just as long as it's not more than 0.25. So I can't remember what it is for our box here, but I'll probably give those guidelines somewhere. So I'm going to set mine to 0.15. And so it should look something like that. And to see how well this worked, we go into simulation mode. But before we do that, let me show you how to parallel lace in case that is a step that you're on. To parallel lace, you click that button, and if you have a curved surface here, you just click on the curve, and then you push enter twice. And then it will just match every curve that you have in here. We want this again to be optimized, percent step over 25%. And tooling is 20, 10, 4,000. Parallel lacing, we are running with a corner radius of 0.125 with a 0.25, a 1/4 inch ball mill with a 0.125 diameter. And then clearance of 0.25, level and depth can be as they are. And you can see that that one will follow the path. If we look down here, it follows the path of the actual cut here. It's kind of cutting in and out. That's not going to get very precise, but for a curved surface, it's going to end up looking pretty good. And if we go back to that sequence for parallel lace, we can adjust the angle of this to 45, and it'll cut it at a 45-degree angle. It looks pretty neat. If you add a second parallel lace in here and make it -45, it'll cut the other direction. So if you do 2 parallel laces for your curved surface, you're going to have something that looks pretty darn sweet. So we're going to end up getting rid of this because I'm not going to actually parallel lace a roughed interior. I want it to be nice and clean. To verify this, we're going to go into rapid results. So yours is the double play sign arrow here. It might not be in this location, but it should look like this image. And loading. Okay, so then we click play, and it ought to mill it out. And I'm going to make this a little bit bigger here. We're going to speed this up, and there it is. You can see this little dinkies on the outside edge. That's no big deal. That is just, those will break off easily in the milling machine. So it should look something like this. It might look pink in certain spots or whatever. Now, there's something wrong with my shape or my code. It was a different shape for a different code, so yours actually will look a little bit cleaner than this. But ultimately, it should look something like this. And so I think one of the things that I'm going to ask you to do is screenshot this. So if you make this thing full size, click and drag it to make it full size, you can screenshot it. So we'll close this out. And the last step is to click the NC generate code. And you can have a name up here, that's fine, just click OK. We're going to overwrite this code. I'm just going to delete that name here. Don't need to have a name for that. Don't need to have a program ID number, but you can put your name in there. Mr. T-Bomb. And it will generate all the code for you, which is sweet because you can copy and paste this into CNC. Now what I would suggest you do, one thing you're going to probably want to do is get this, delete this line. We don't have a tool change, T00. We don't want to have that. Double check your spindle speed. Mine for some reason changes to 2000. It used to be 4000. And then the last thing you're going to want to do before you save your code is add an X2, Y2, oops, Z2 on here to move the milling machine out of the way before you turn the program off. So once you've done those things, you've added that in there, you've gotten rid of this piece, check your spindle speed, then you can save it, save the code, name it something, okay, so make sure you save it in a certain location, and then you can open that saved code in CNC, and it should be all ready to go. This is the one piece that you might need to change, is G17. If you did some parallel lacing, but we can talk about that. If you have an issue, if it says K code invalid, you're going to have an issue with this G17. You'll just need to change that to either G18 or G19. So hopefully that will get you going with Edgecam.